We normally use aligned magnets to generate torque. To establish a frame of reference, we have designed reaction blocks to work with offset magnets so we can use a solid steel bar as a reference. A 5mm offset is selected because with our 0.1mm measuring capability, it gives us 2% accuracy expectations, and Vilma Cinco likes the number 5. This is a pictorial representation with no offset. And this is the schematic. A reaction block is placed between two parallel magnets. Equal gaps primarily establish the flux density. When torque is generated, the only contact is at the two L-shaped pivots at opposing ends of the magnets. The test procedure. Adjustment screws are loosened and the test fixture is assembled with plastic shims between the magnets and the reaction blocks. Magnets are tapped into place with the desired offset and measured with digital calipers. The screws are tightened, the plastic shims are removed and replaced with aluminum pivots at opposing ends of the magnets. Weights are incrementally added to the hook near the end of the pivot arm until the pivot block disengages. The weights and the pivot arm length are measured and used to calculate the breakaway torque. The torque is compared with the torque using the solid steel bar. Higher torques can only be attributed to higher flux density with higher energy, or a vector change where flux density and energy can be lower. We have three reaction blocks. We have a solid steel bar, a torque generator for a 20mm magnet spacing, and a torque generator for a 40mm magnet spacing. Both torque generators consist of 50+ elements glued together. Obviously, the elements can only be defined as sources or passive elements. Some experiments include copper magnet wire. Aluminum covers are needed to hold the parts together. Magnet forces easily break the glue bonds on generators without covers. Covers are also used on the solid steel bar to maintain consistent gaps. The torque generators have less than 1 Newton pull force on the working surfaces, which is insignificant compared to the 180+ Newton pull force of the magnets. The combined reluctance of the reaction blocks and the air gaps can be measured using high-frequency, low-power AC induction coils on the return path. The test is simple. We add weights until the pivots disengage. Repeatability is better than 10 grams. For this test, anything over 500 grams, the weight that disengaged the solid steel bar is either free energy or indicative of free torque to drive the motor. Free energy is impossible, which only leaves free torque and fraud as the possibilities. So first we'll start with 369 grams. We'll increase it to 700, 750, 800, 836. Oh, there it goes. Let's try it again. A little bit more. A little bit more. And that's it. So, what do we have here? With the solid steel bar, it took 500 grams to disengage. With the torque generator, it takes 800. That means that we have more than 6.6 Newton meters of torque generated by the torque generator. That torque is about the same torque that's in your washing machine motor. So in this tiny space, we have produced the same torque as a 3600 RPM washing machine motor. I think that's pretty good.